Hi friends, this is Alojan here. Welcome to my networking channel. Hope all are doing good. And today the topic I'm going to discuss about how to configure MPLS with multiple customers. That means multiple VRF I'm going to configure. So here I configured 4 customers: CE1, CE2, CE3 and CE4. So CE1, CE2 I'm going to configure in VRF red. So CE3 and CE4 I'm going to configure VRF blue. So I'm going to show what is VRF exactly. So this is an MPLS architecture where P1, P and P2 are collectively called as the MPLS backbone routers, and these are the customer edge routers. So they don't have any knowledge of MPLS. So we need to enable the communication from CE1 all the way to CE2 and CE3 to CE4. So for that we need to perform the basic configuration. So before that, let us do a quick overview how the MPLS works exactly. So the packet will be routed from CE1, that is the customer edge router placed at the customer premises, to provider edge router. So in the provider edge end, what happens, we'll be pushing the label, what we called as a label imposition. So it will push the label onto the packet, and this labeled packet or the prefix will be sent to the provider core router. In the core router, it will perform a label swap. Say this label is 16, it will swap from 16 to label 17, and this label packet will again send to PE2. So at this provider edge router, again this label will be popped or removed, and then it will send only the packet, that is the unlabeled packet, to the customer end. So this is how the MPLS work. So what are the basic things I'm going to configure is I'm going to configure 2 VRF. So there are totally 4 customers. So 2 customers I'm going to configure VRF red, and another 2 customers I'm going to configure VRF blue. And after that I'm going to configure to this individual corresponding interfaces, right? So VRF is a virtual routing and forwarding information. So instead of a single global routing table, I am just segregating into individual virtual instance. So each and every virtual instance is a single virtual routing table for individual customers. So we want to maintain the uniqueness of each and every customer. So for that reason, I'm using virtual routing instance or the virtual routing table, what we call it as a VRF. So under that VRF, I'm going to assign RD and RT. So RD is a route distinguisher which is used to distinguish routes from the other customer routes. So for that reason, we are using RD. So RD is a 64-bit value, and RT is a route target which is used for importing and exporting the customer routes between the MPLS routers. So for that reason, we are using VRF, RD and RT. And second thing, what I'm going to do, I'm going to configure Ldp and IGP. So IGP is nothing but a interior gateway routing protocol. So here for the configuring these MPLS, I'm going to use OSPF as a routing protocol. So why I'm going to configure OSPF in Ldp is this routing protocol will automatically trigger the Ldp, that is the label distribution protocol, and it will advertise the labels between these routers. So already told we'll be sending the label, right? So for advertising the label between the MPLS routers, I need a protocol. So for that we are using Ldp. Ldp is a label distribution protocol used for advertising or distributing the labels between the MPLS backbone. So that's the thing I'm going to do. Second thing. And the third thing, I'm going to configure the MPBGP. That is a multi-protocol BGP between provider edge 1 and the provider edge 2 router. So what is MPBGP? So I already told, whenever this labeled packet is sent to this core router, what happened? Always send RD information as a part of prefix. So it will be sending RD and the prefix combination. So that we call it as a VP and V4 route. See, RD is a 64-bit value, I already told, right? RD plus this prefix is a 32-bit value. So this combination we call it as a VPN V4 route. And for advertising this VPN V4 route between this provider edge router, we are using the MPBGP, that is a multi-protocol BGP. So once that is done, then I will be configuring the BGP between the CE1 and PE1 and CE3 and PE1. So both I'm assigning different autonomous system. So AS1 is for CE1, AS3 for CE3, and this AS for 2, C4 for AS4. So now let us go to the configuration. I am going to configure the basic VRF, RD and RT. So let us configure 2 VRF, right? There are totally 4 customers. So these 2 customers I indicated in red. So this is why I'm going to configure VRF red, and the remaining 2 customers I'm going to configure VRF blue. So after creating this VRF, so always keep it in mind, this VRF I am going to configure in this provider edge router, and after that I will be configuring in these individual interfaces, right? So let us go ahead and configure. So let us go to PE1, go to the configuration mode IPVRF red. So let us make the RD as 1:1. So RD, this combination is 1:1. That is, 1 is for ASN, autonomous system number :1. So this can be any format I can give, but I have given this 1:1. And RT, route target. So both. It is for importing and exporting. So both is nothing but it indicates both import and export of the customer routes. So route target both 1:1. Similar way, let us go create the VRF for blue. How to create IP VRF name, let us make it as blue. And for distinguishing between the customer routes, I'm just going to assign some other RD value. Let us say 2:2 and the route target both 2:2, right? So the thing is that this we have configured on PE1 and the same thing I'm going to configure on PE2 also. Let us go to PE2 and go to the configuration mode IPVRF red and RD what we assign 1:1 and the route target both 1:1, right? Yeah. So the similar way let us configure for VRF blue IPVRF blue and RD is 2:2, right? We have configured. So both should be on the same thing, both PE1 and PE2. Let us see. Yeah, blue for 2:2 and route target is both import and export, that is 2:2. The same format we can give, but only the purpose will be different, right? So once this is done, what I'm going to do, I am going to activate on this corresponding interface. This interface I am going to activate according to the customers. So this I already indicated in red, so I have to assign this VRF forwarding red and this is for blue. Similarly, this is for red, that's the reason indicated here. This is for customer blue. So let us go to PE1 and go to the configuration mode interface. This is faster than at 0/0. So faster than at 0/0 IP VRF forwarding already created the VRF name red. So now it will remove the interface. I have to go assign this IP address 192.168.12.2 255.255.255.0. Let us activate this. So first let us finish up the red thing. So I'm going to configure this also faster than at 0/0. Go to PE2. Go to the configuration mode interface faster than at 0/0 IPVRF forwarding red. So that will be removed. Interface will be removed again. So we have to activate this interface 192.168.45.1 255.255.255.0 and let us activate the interface. So I have completed this red configuration, VRF red configuration. So I have to enable in the configuration mode and also in this corresponding interface facing the provider edge. So both the things I have done. Now let us activate the VRF for blue customer. So let us go to faster than at 1/0. Go to PE1 and go to faster than at 1/0. IPVRF forwarding is blue. Right? So again it will remove. So IP address 192.168.13.2 255.255.255.0 sorry 0 and no shed, right? So now let us go to PE2. So PE2 and let us assign this faster than at 0/1. PE2 faster than at 0/1 IPVRF forwarding blue. So it is removed again. I'm going to activate it. IP address 192.168.46.1 255.255.255.0 and let us activate the interface. So I have done the basic configuration. VRF configuration, this is completed. So now let us check the corresponding VRF thing. So show IP VRF will show the corresponding VRF blue and red, right? So red 1:1 and this 2:2. Let us go to PE2. Show IP VRF, right? So now what is the second step is I'm going to configure the LDP and IGP configuration. So I'm going to configure the LDP and IGP for PE1 and PE2 for advertising the labels. So this entire MPLS backbone routers, I'm going to configure this LDP and IGP configuration. So second thing I'm going to configure is how to configure LDP and IGP configuration. So LDP is a label distribution protocol used for advertising the labels between the MPLS routers. And IGP is a routing protocol I'm going to use for OSPF. So this OSPF routing protocol will trigger the LDP updates between the neighbors. So that is the purpose of configuring both LDP and IGP together. So I'm going to activate this on PE1, P and PE2. So I have to activate only on the MPLS backbone. So let us go ahead and configure the second configuration. So go to configuration mode. So router OSPF 100 And the network statement. What I'm going to define is only this MPLS network, that is 192.168.23.0. 192.168.23.0, 0.0.0.25 area 0. That's a backbone area. So I define the loop back address as 2.2.2, 0.0.0.0 area 0. So we have to advertise the LDP, MPLS, LDP is a command, auto config. So this is for activating the LDP between the MPLS routers. So now the same thing I'm going to configure on provider router and provider edge router. So let us go to the core router, that is P router, go to the configuration mode and router OSPF 100. So it has two statements, network 23 and 34 plus the loopback address. So the network is 192.168.23.0, 0.0.25 area 0. Similar way 34.0, 34.0 area 0. Then the network is the loopback I have to define. 3.3.3 I already defined this loopback. I am advertising in the OSPF area 0. Then let us activate the MPLS. MPLS LDP auto config. Yeah. So the similar way I'm going to configure this on PE2. So go to PE2 router, go to the configuration mode and router OSPF 100. Network is 192.168.34.0. So this is the MPLS network I'm going to define. 0.0.0.25 area 0. Then network is 4.4.4. This is a loopback address followed by 0.0.0.0 area 0. Then let us activate the MPLS. MPLS LDP auto config. So now I activated the MPLS LDP configuration on PE1, P and PE2. So this second thing is done. LDP and IGP I already configured on the MPLS backbone routers. So now let us check the configuration. So let us go to PE1, show MPLS. There are two things we can check. Show MPLS interfaces will check whether the MPLS LDP is active or not. So it's showing LDP is already active. So now let us check the neighbor. MPLS LDP neighbor is a command. So the neighbor is already up. 3.3.3 is already up. The source is the loopback. So it is established already an TCP connection with the neighbor. So let us see from provider router. Show MPLS LDP neighbor. So this is two neighbors, right? One is 3.3.3 and 4.4.4. So already established a neighbor relationship with PE1 and PE2. That's an LDP neighbor relationship with PE1 and PE2. So let us check from PE2 also. So go to PE2, show MPLS LDP neighbor. So this also the neighbor is coming up. So now the third thing what I'm going to do, I have to configure the MPBGP between the provider edge 1 and provider edge 2 router. What is MPBGP? It is a protocol used for advertising the VP and V4 routes between PE1 and PE2 router. So VP and V4 already told it is a combination of RD. So we already sending the RD information plus prefix to the provider router. So this combination of prefix and RD we call it as a VP and V4. So for advertising this VP and V4 between the PE1 and PE2 router, I need to configure this protocol MPBGP. So how to configure? Go to provider edge router BGP 234. So all this I'm going to configure in 234 autonomous system number. So now let us activate. Neighbor is 4.4.4. So that is a loopback address of PE2. Then the remote ASS I'm going to configure this as a IBGP neighbor. So both are all the three routers are in the same IBGP neighbor. So then neighbor 4.4.4 update source loopback. So since I established a neighbor relationship using loopback, I'm using this. Then let us activate the address family. So address family is a thing we are activating for activating the VP and V4 using the MPBGP protocol. So then let us go neighbor 4.4.4 activate. So this is a command you have to do for establishing the VP and V4 route. So after this, go to PE2. Again go to PE2. Go to the configuration mode. It is in autonomous system number 234. Neighbor is PE1 neighbor is 2.2.2. Remote AS is 234 IBGP neighbor. Similar way, update source loopback 0. So then activate the address family. Then the neighbor is 2.2.2 activate. Right. So now I activated the VP and V4 routes between PE1 and PE2. So only one more thing is pending. Since we are establishing the VPN v4 route using MPBGP, so there is no need for IPv4. So I can disable that using the same command. How to do that? Go to PE1, go to the show. Before that, let us check it out. Show BGP VPN v4 unicast all summary. So let us see whether the neighbor is coming up. Yeah, the neighbor is coming up. So let us see from PE2 end also. Neighbor is coming up. So now let us disable the IPv4. How to do that? Router BGP 234 address family IPv4 no neighbor 4.4.4 activate. That's a command. So that means it will disable the IPv4 between the neighbor. Sorry. So go to configuration mode, router BGP 234, address family is IPv4. So no neighbor 4.4. Activate. So that means it is asking for the oh sorry, this is the wrong number, right? So router BGP 234 address family IPv4. So no neighbor 2.2.2 activate. So that's a neighbor, right? So this is for 2.2 and this is for 4.4. Okay, then go to PE1 and go to the configuration mode. Router BGP 234 address family IPv4 no neighbor. So this is 4.4.4 neighbor 4.4.4 activate. Okay, so I done with PE1 and PE2. I disabled the IPv4 and we activated the VPN v4 between the PE1 and PE2 using the MPBGP protocol. So that is the third configuration. So now let us check it out. So now it has come to the active state, right? So now you're able to see everything is coming up. The third configuration is done. So now what is the fourth one? Fourth one, I'm going to configure the BGP between CE1 and PE1 router. So let us first configure for VRF red. So this VRF red we'll configure. Then after that we'll configure for VRF blue, right? So that customer we can configure. So let us go to CE1 first. So let us go to CE1 and go to the configuration mode. So one more thing is pending. So for checking the MPLS forwarding table, there is a command called show MPLS forwarding table. So this forwarding table will show all the information, like what are the data I'm going to forward. So MPLS is it will forward the packet based on the label information. So how it is identifying the label means there can be several customers. So each and every customer can be different label. So based on the label information in the forwarding table, it will come to know which customer the VRF belongs. So based on that information, it will forward the packet. So that is the main purpose of MPLS, right? So it will always forward the packet based on the label information. So right, so that is the thing you are seeing. So MPLS forwarding table will show all the prefixes and the tag. So attached tag is nothing but the label tag. So these are the key information you will find in the show MPLS forwarding table. So there are two planes in the MPLS. One is a control plane. It is used for exchanging the routing and the label information. So the routing information is exchanged using the routing protocol OSPF, and label information is advertised using layer LDP protocol. That is a label distribution protocol. So that is done using at the control plane. So in the data plane, we'll be using FIB and LFIB. So what is FIB? Is a forwarding information base which is used for forwarding this unlabeled packet. Right? That is for that we are using FIB, and LFIB is nothing but a label forwarding information base which is used for forwarding the label packet from one router to the other provider edge router. So for that reason we are using LFIB. So that is the thing you are seeing here. Show MPLS forwarding table will show all the prefixes and the attached label. So that's the thing you are seeing here. So now the fourth step is we are going to configure the BGP between CE1 and PE1 router. So now let us activate the configuration between BGP and CE1 and PE1, right? So that's the fourth configuration I'm going to activate between the customer edge router and the provider edge router. So for that, I'm going to configure individually. So this is VRF red and this VRF red. So let us configure this CE1 and CE2 first of all. So after that, let us go over with this configuration CE3 and CE4. So let us go to CE1, go to the configuration mode, router BGP1. So that's the autonomous system number I'm going to do. So router BGP1 and the neighbor is 234 MPLS backbone router. So the neighbor is 192.168.12.2 and the remote is 234, right? So now I have to advertise the prefix. So let us see the loopback address, what I define here. So let us see it is. So the loopback I define is 1.1.1. So I'm going to advertise that as a prefix. So router BGP1. So neighbor I already defined, right? So the network is 1.1.1 and the mask is 255.255.255.255. So that's the thing I defined here. So similarly, let us finish it off from PE1 and also. So let us go to PE1. Configuration mode router BGP 234. So here is the command you have to always keep it in mind. So here I am going to define as IPv4 since customer is an IPv4 environment. So address family IPv4 VRF, we have to define that VRF value, that is red, right? So VRF name is red. So I have to define that name VRF red. So this is for differentiating the customer, right? Different customers. So address family IPv4 VRF red. So then I'm going to define the neighbor. So what is the neighbor is 12.1. So 192.168.12.1 and the remote AS is 1, right? And let us define the network 192.168.12.0. Mask is 255.255.255.0. So we are done with this CE1 and P1 configuration for the VRF red customer. Similar way this customer also will do. That is also belong to the same customer, that is CE2. So let us go to CE2. I hope you are following this. So router BGP2, and the neighbor is 192.168.45.1, right? 192.168.45.1 and the remote AS is same autonomous num, that is MPLS backbone 234. So then let us define the network. Show IP interface brief. I'm going to check the loopback address. So the loopback what I'm going to define is 5.5.5. So go to router BGP2, neighbor is 45 and the network is 5.5.5. Mask is 255.255.255.255. Okay, so now you are done with this CE2 configuration for VRF red customer. Similarly, PE2 also I'm going to configure. Go to PE2 and go to the configuration mode router BGP234 address family IPv4 VRF red, right? Idea V4 and VRF is red. So that's the thing. VRF is a red one, red customer, right? So VRF red. Then similar way we have to activate the neighbor. Neighbor is 45.2, 192.168.45.2 and the remote AS is 5, right? So the remote is not 5, I think it is CE2 what we have done, it is 2. So the PE1, the remote AS is 2. So remote is 2, then let us define the network 192.168.45.0 and the mask is 255.255.255.0, right? So for now we have done the established for CE1 and PE1, that is for VRF red customer, and CE2 and PE2. Let us check the neighbor relationship. Go to CE1, show IP BGP all summary. So the neighbor is up. Similar way, let us go to CE2. And CE2 is also neighbor is coming up. Show IP BGP all summary. So the neighbor is up. So now what are the thing is pending? I need to configure for this corresponding customer, that is VRF blue customer. Similar way, let us go to CE3. So go to CE3, go to the configuration mode router BGP. What's the thing I'm going to assign? 3. Router BGP 3 and the neighbor is 192.168.13.2 and the remote AS is 234 and what is the loopback is 11.11.11. So network 11.11.11.11, mask is 55.55.55.55. Okay, so I have done with this CE3 for VRF blue and similarly I am going to corresponding this interface I am going to configure IPv4 VRF blue because this is for VRF blue. So let us go to PE1. Go to the configuration mode router BGP 234. So this will come under different VRF. VRF blue right? So the neighbor is 192.168.13.1 and the remote AS is, what is the AS we have given as 3. So now let us define the network. 192.168.13.0 and the mask is 255.255.255.0, right? So now let us check from CE3, it should come up. So let us go to CE3. Let us see the neighbor is coming up. Show IP BGP all summary. See, the neighbor is coming up, so that means the VRF blue customer is also up. So the similar way, the same thing configuration I'm going to configure on this CE4. So let us go to CE4, go to the configuration mode, router BGP 4, right? Router BGP 4, and the neighbor is 192.168.46.1 and the remote AS is 234. That is the MPLS backbone autonomous system number, and the network is the same loopback I'm going to define 55.55.55.55 and the mask is 55.55.55.55. Okay, so once I done with this, now let us go to PE2. So let us go to PE2, go to the configuration mode, router BGP 234 and the address family is blue. So here you are able to see, right, our neighbor 45.2 VRF red is coming up. So that is for red customer. Similar way, let us see for here VRF blue, and the neighbor is 192.168.46.2 and the remote AS is 4. Similar way, network 192.168.46.0 and the mask is 255.255.255.0. So now we are done with the configuration. Now let us see whether the neighbor is coming up for CE4. CE4, let us check. Show IP BGP all summary. So this also the neighbor came up. So we are done with all the configuration. Now we have to check for the individual routing entries for VRF red and VRF blue customers. So let us check from CE1. Let us see the routing entries. So what are things I have done is, first I activated the VRF, RD and RT for on all PE1 and PE2 router. We activated it. Then I activated the LDP and the IGP configuration. So these are the basic configuration we have to do for all MPLS configuration. So this LDP and IGP are activated on PE1, P and PE2. This is for advertising the label. And third thing, I established the VP and V4 relationship between provider edge 1 and provider edge 2 router. And fourth thing, I activated the BGP, IPv4 BGP between the customer edge and the provider edge router. So now let us check the routing entries from CE1. Show IP route. Yeah, so now we are seeing able to see the entry. So this I'm going to see for CE1. So I'm going to want to reach from CE1 to CE2, that is 5.5.5. So this loopback address is 5.5.5. So let us see. So this loopback is 5.5.5, right? So I need to reach from this one, trace. Before that, let us do a ping. So ping 5.5.5 and the source is loopback 0. So I'm able to ping. Let us do the trace 5.5.5. Source is loopback 0. So this is taking this corresponding path 12.2. So see, this is taking 12.2, 23.2 and 45.1 and 45.2, right? This is for red customer. It is working properly. And let us see from CE2 end also. CE2, let us see. Show IP route. So the trace is 1.1.1 source loopback 0. Yeah, I'm able to reach for this corresponding customer. This is for red customer 45.1, 34.1, and that is trace you'll see. 34.1, 12.2 and 2 and 12.1, right? That is working fine. So now let us check for VRF blue customer. So go to CE3, show IP route. So the remote thing is 55.55.55.5. You are able to see, right? 50, that is for 23.2 customer. Let us see the loopback address for CE4. 55.55 is the remote address. Let us ping 55.55. I'm able to reach. Let us do the trace 55.55.55.55 and the source is loopback 0. So this path will be entirely different from this corresponding path. You are able to see, right? C1 is taking the different label 19 by 20. And if you are seeing this path C3, it will be different 19 by 22, right? So that means each and everything will take a different path. Each and every packet will be assigned with a different label for a different customer. So based on the label, it will always forward the packet. Only by identifying the label, the packet will be forwarded. So that information will be there in the MPLS forwarding table, right? So now let us see from CE3 already seen. Now let us see from CE4. So CE4, let us do the routing entry. Show IP route. I am able to see, and the trace 11.11.11.11 and the source is loopback 0. So I'm able to reach. This is for blue customer, right? So the 46.1 and the 34.1, 13.2 and 13.1. So 13.1, 13.1. So now it is working properly. We're able to see now how to configure the MPLS for this different VRF. So two VRFs are assigned, VRF red and VRF blue. So now let us check the MPLS forwarding table. Show MPLS forwarding table. Right, you are able to see. So you can see for individual customer, let us see VRF red. So VRF red, this is the MPLS forwarding table, and VRF blue, this is the forwarding table. For individual customer, there will be a separate forwarding table, and based on that information, the packet will be forwarded from the one end to the other end. So always forward the packet based on the label information in the label table, right? That is a label forwarding table. So one is a control plane and second one is a data plane. So this I already explained in my previous video. Let us see. Go to C1. So this I already told that there are two types of label. One is a transport label and another one is a VPN label. So the transport label we are using for transportation of label from one end to the other end. So this label will is swapped. So say for example, this transport label there is saying 19. So that 19 label will be attached and sent to the provider core router. And at the receiving end, this label will be swapped. For example, CE1, let us see CE1 to CE2, let us see. CE2, you can see the label is 18. That means the label is swapped from 17 to 18. So that is done with the transport label. So the first one is the transport label. Sorry, this is 19 to 18. It will be transporting, it will be swapping from one label to the other end by this provider router. And again, this label packet will be sent. And at the receiving end, it will be again popped or removed. So it will be adding both the transport label and the VPN label. That's the thing I want to say. So this is a transport label always will be changing, but the VPN label remains the same from source to end. But only difference is at both the transporting end, it will be adding both the transport label and the VPN label, and at the receiving end, it will remove both the labels. So it will be seeing here you are able to see only the unlabeled thing. That means it is sending only the packet, right? So 45.1 only you are able to send only the packet to the CE2. So that's the process of MPLS. So I hope you enjoy this video. Thanks for watching. Please subscribe for more videos. Thanks and have a wonderful day. Thank you.